and welcome back. It's been probably a whole 30 seconds for you, but it has been a couple of hours for me. I went into the school and participated in the circle this morning, and I thought it was amazing. I absolutely love when we have those circles, and I thought that the purpose for this one was important, and I hope that you guys understood where we were coming from as a school and how important all of this is. If not, but we did just talk about parts of a circle. We're going to go on to page 2 here. We're going to talk about the area of a circle and a sector. As we just discussed, the sector is any wedge of a circle that includes 2 radii. 2 radiuses? No, it's radii, I'm pretty sure. All right, so first we're going to talk about the area of a circle. The area is just the inside portion of an object. So if you have the area of a rectangle, it's just the inside portion of the rectangle, right? I hope this is extreme review for you guys, but I am going to discuss every little thing in case anybody needs a brush up. Okay, so the area of a circle is pi times the radius squared. Now for pi, we are going to use 3.14. The actual value of pi goes on forever. I used to know a lot of them, now I just know it's 3.1415, and I can't remember beyond that. But for our purposes, we're just going to use the first 3 digits, 3.14. The radius, anything that goes from the center of the circle to the edge of the circle, and I hope you can see that that would be the same no matter where you went to, right? Squared. If you remember, this squared is called an exponent. And an exponent just means how many times you multiply the object it's attached to by itself. So if you're talking about multiplication in general, multiplication is related to addition. 3 times 4 means 3 fours. So 3 times 4 is 4 plus 4 plus 4 is 12, right? Well, the exponent is very similar. If I had 3 squared, where the multiplication you're adding, this is multiplication. So it's just 3 times 3 equals 9. Or 3 cubed would be 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. And then, we could go even further, but I'm not going to, because then I'd have to multiply 27 by 3, and I don't want to. But you get the point. The exponent just tells you how many times you multiply the 3, or whatever the number coming with the exponent is, by itself. Right? So it's very, very related to multiplication in this relationship here. If that doesn't make sense to you, just remember your exponent tells you how many times to multiply the number by itself. Boo, 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 boo. Gonna erase this stuff. Da, 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 da. All right, so pi r squared. Pi is the ratio of a circumference to the radius. Just like boys to girls in the class, or any other ratio you can think of. People born in June versus people born the rest of the year. This is just the ratio of the measure of the circumference to the measure of the radius. And it turns out that's a constant. No matter how big or small your circle is, that ratio stays the same, and it is 3.14. 1597? I don't know, I'm just guessing. Anyway, that's what pi is. So get that in your notes if you don't already know that. So the area of a circle, pi r squared. pi times the radius squared. So whatever the radius is, you multiply by itself, multiply that by pi, boom, that's your area of a circle. The area of a sector is almost exactly the same thing. But to help you understand the area of a sector, we're going to talk about a couple of things. First, theta. The Greek letter theta is commonly used in math to mean the measure of an angle. So the theta of this angle right here is this measurement. Everybody see that? So theta is the measure of an angle. So let's say this was, I don't know, 15 degrees. Then theta equals 15 if this right here was 15 degrees. Does that make sense? You're not answering me, so I'm assuming it does. Oh wait, you're not here. All right. Yeah. So now that we know what theta is, we have to understand something else. Percentage. Again, this should be reviewed to you guys. Percentage equals 3 lines. Number out of 100. Per 100, percentage of 100. So 30% would be 30 out of 100, right? Well, circles don't have 100 degrees. Circles have 360 degrees. So a percentage of a circle would be actually the number out of 360. So if this was, what did we say? We said it was 15 degrees. Be 15 out of 360. So if you divide, there's a calculator in here. I was going to do it on my own, but there's a calculator I can show you. Boop! Calculator. 15 divided by, oh, I just wrote 5. 15 divided by 360 equals what? So that is 0.04% of the no, it's not. Ha ha! It's 4% of the circle. Boop, boop. Just like 30 out of 100 would be 0.30. Move it that way twice to get 30%, because out of 100, right? 100 100ths. So ignore Mr. Jeremy's brain dead silliness right there, and know that 15 out of 360 is 4%. All right, now I'm going to move this little guy out of my way. All right, so where was I? Oh, we were explaining area of a sector. Well, area of a sector is almost exactly the same thing as area of a circle. You notice we have times pi r squared. So times the area of a circle, and we have theta divided by 360. So it's the percentage of the circle times the area of the circle. Bam! That's pretty sexy, right? It looks intimidating. This whole thing, I got to admit, theta over 360 times pi r squared, that can look intimidating. But when you break it down to what it means, it's not that bad. It's just percentage of a circle times the area of a circle. So that gives you the area of what that percentage of that circle is. And you can feel wicked smart, because that looks kind of intimidating. And if you can explain it, then that makes you genius. Okay. So this last one right here, we're not going to go over. Just know that radians is another way of measuring the parts of a circle. We are going to use degrees. Degrees. I don't believe we're going to get into radians in this course. Have to look ahead further, but I really don't think we are. Just know that radians is an alternative to degrees, and rather than being based on the seemingly arbitrary number of 360, it's based on the radius and pi and cool stuff like that. So it's a little bit more, it makes more sense. It's just not commonly used. We use degrees all the time. All right? So yeah, we don't have to worry about the area of a sector as 1/2 the radius squared times the measure of the angle, or 1/2 r squared theta. Don't worry about it. I just wanted to explain it to you because it's here on the page. Okay, let's see. Yes, that is everything I wanted to cover. So I'm going to end here, and we're going to call that good. Next, we have some worksheets and things that we're going to do based on the math that we just learned.